Hi everyone, in this video I will focus on the steps of solution to determine the bearing capacity of shallow foundation using the Meyerhof equation. So in this Meyerhof bearing capacity theory, it will consider for all types of shallow foundations, whether it's square, whether it's continuous or rectangular foundation. And also, it will take into account the shearing resistance along the failure surface in soil above the bottom of the foundation. As you can see here, the portions of the failure surface marked as GI and HJ here in this area. And also, we'll consider if the load of the foundations may be inclined. The load here may be inclined as a angle beta. So this is the equations of the Meyerhof bearing capacity. You can see here that they have the shape factors and also have the depth factors and the load inclination factors. And as like Terzaghi, it's also have the bearing capacity factor NC and QN and gamma. So in this Meyerhof, the equation will have the shape factor. So this is the relationship related with the shape factor, the relationship between the size of B and L. And also you can see the depth factor here in a two different condition. If the dF over B is less or equal to 1, or for the condition dF over B more than 1. And here we have the inclination factor, okay, that will consider the angle of beta, the inclinations of the load on the foundation with respect to the vertical. So here is the beta. So if it directly here, so meaning that the beta will equal to 0 degree. And here we have the bearing capacity factors. The value is slightly different with the Terzaghi. So you need to refer to the correct bearing capacity factor table. So here is the Meyerhof bearing capacity factor with the value of angle of friction here. Okay. So we will look through to the example number 2. That we need to use the Meyerhof general bearing capacity equation to determine the allowable bearing capacity, net allowable bearing capacity, allowable load, and net allowable load by using the factor of safety or Fs equal to 3. So the size of the foundations is 2 times 2. It is a square foundation. So the B is equal to 2 meter and the length is equal to 2 meter. Alright, so what is the first step? So the equation to be used is the Meyerhof equation. As you can see here, there are the third term, okay? And then we need to identify the bearing capacity factor based on the angle of friction. So we will refer to the table. Alright, so from this table, you need to identify at the angle of friction 25, what is the NC, NQ, and gamma. So now we have the value of the bearing capacity factor. So what is the next step? We need to determine the shapes factors. So as we refer to the previous equation for the shape factor, so we have the FCS here, which is equivalent to 1 plus over B over L times NQ over NC. So we have all the information. B is equal to 2 and L is equal to 2. And also we have the informations of NQ and NC. You can straightforward calculate the FC. So it's equivalent to 1.51 here. Okay, now we need to continue with another shape factor. So we have the FQS. So this is the equation. So now using the angle of friction. So we have the FQS 1.47 and F gamma S. Again, we will use B and L. So you will have the F gamma S is 0.6. Now, we need to determine the depth factors. So this is the equation. We need to check first the df over b, whether it's less or more than 1. So if it's less than 1, so we have 0.75, which is less than 1. And the condition is also angle of friction is more than 0. So this is the equation that we will be used for FQD. So just substitute the angle of friction and also the df and b. So you will have the FQD is 1.23. Then after that, we need to have the FCD that is actually equivalent to FQD minus 1 minus FQD over NC, tangent angle of friction. So just substitute with all the values that we have. We have already the FQD and we have the NC, also the angle of friction. So this is the FCD, 1.25. And finally, F gamma D is equivalent to 1. If you refer back to the depth factor information relationship, the F gamma D will equal to 1 for the case of angle of friction more than 0. Now, the next step is to determine the inclination factors. Alright, so here we have the inclination factors. This is the equation. So in this case, the beta will be equal to 0 degree. So now you can substitute beta here with 0. And then you can get the FCI, which is equivalent to FQI. So it's equivalent to 1. And then finally, we have the F gamma 1. Again, we need to refer to the beta inclination factor. So here beta equal to 0. So now you can have the F gamma 1 equivalent also to 1. Alright, so now we have all the information. We have all the factors. We have the shape factors. We have the depth factor. And we also have the inclination factors. So we already calculate the Q for gamma dF here. So we can identify the ultimate bearing capacity. We can calculate the ultimate bearing capacity by using this equation. So we substitute all the information. So this is C, NC, FCS, FCD, FCI. And then we have the Q here. And then NQ, FQS, FQD, and FQI. Plus with half times with the gamma unit weight. And then times with the B, size of the foundation, the B size. Times with the N gamma here. Times with the F gamma S. And F gamma D. And also F gamma I. Alright, so now you will have the ultimate bearing capacity is 1362.18 kilonewton per meter square. Okay, so we're back to the question that we need to determine the allowable bearing capacity. Okay, so how to get the Q allowable is exactly similar with the previous video. So we will use that QU over Fs, factor of safety. So we will get the Q allowable bearing capacity is 454.06 kilonewton per meter square. Alright, now we already complete the Q allowable. So now we want to proceed with the net allowable bearing capacity, Q net allowable. Alright, so this is the equation. Okay, so you can get the Q net allowable is 445.81. So we just substitute with the information that we have calculated before. Okay, so now moving forward to question C, we need to determine the allowable load, capital Q allowable. Alright, so we need to times with the area of the footing, the Q allowable, the times with the area of footing. So the size of footing is 2 times 2. So you already have the Q allowable. So we can get the capital Q allowable is 1816.24 kilonewton. Remember that the unit for this Q allowable, capital letter Q is kilonewton. And finally, we need to determine the net allowable load, Q net allowable. All right, for the Q net allowable, we will use the Q net allowable bearing capacity times with the area of footing. All right, so we already have calculated this value in question B. All right, so we just time with the area 2 times 2. So you will get the Q net allowable load in kilonewton is 1783.24 kilonewton. So that's how we use the Meyerhof general bearing capacity equation by using all the shape factors, all the depth factors, and also the inclination factors. Thank you.